Hello friends, in this session of Cisco Packet Tracer, uh, we are going to see how networks belonging to different OSPF domain they can interconnect by the use of BGP routing protocol. Uh, uh, so first of all, BGP means Border Gateway Protocol. It is used to connect two networks which are belonging to two different ASN number. In our previous videos, we have seen this EIGRP routing protocol and the OSPF routing protocol. So both of them are interior gateway protocol, means both of them will work only in one ASN number, in only one particular ASN. So here we need to transfer packet outside of one ASN to another ASN. So we require one routing protocol which can interlink the two ASN. So we are using the BGP protocol. Here in my topology, here I have taken two OSPF domain, OSPF1 and the OSPF2, in which the router 2 is the edge router for this OSPF1 domain, and the router 4 is the edge router for this OSPF2 domain. Uh, Here, this in OSPF1 domain, I have taken two subnetwork having the IP address of 192.168.1.0/26 and the 1.64/26. Likewise, for OSPF2 domain, the two subnetworks are 192.168.2.0/26 and the 2.64/26. So first of all, we need to configure the IP address for the respective interfaces. Let's start from router 0. So now we are in the router 0. So I am directly going into the CLI mode of the router. No. Level 50. Here first our interface gig port. Yes. The address of this interface 192.168.1.1, having a second mask of 255.255.255.192 and the no shutdown. They are shared by entity, say 0/1/0 IP address of 10.0.0.1, second mask 255.255.255.252 and the no shutdown. In my previous videos, I have used this static IP to assign IP address to my PCs, but here I will enable DHCP. So DHCP, let's say some particular name for our this particular pool. Let's say site 1 0 subnet mask is 255.255.255.192, and the default router gateway 192.168.1.1. We have configured the interface for the router 0, so let's do for the router 1. So CLI mode, enable config t, and the interface IP address 192.168.1.255.255.255.192, and the no shutdown //0 IP address 10.0.0.5 55.255.255.252, and the no shutdown exit. And here also DHCP will be enabled. P pull site 2 168.255.255.192, default router gateway 32.168.1.65. Okay. So router 1 interface also IP has been assigned. Now for router number 2, router 2 has this 3 serial port. //0 IP address dot 0.0.2 and subnet mask of 255.255.255.252 and no shutdown. Get next interface /1/1 IP address 10.0.0.6 255.255.255.252 no shutdown and third serial port IP address 10.0.0.9 255.255.255.252 no shutdown. So router 0 1 2 finish. So next is router 3. It has two serial port. This is 011 and the SC 010 and the SC 011. So router 3. Router 3 SC 0/1/0 P address 10.0.0.10 and subnet mask 255.255.255.252 now shut down. And 0.0.13 subnet mask 255.255.255.252. So router 3 is finished. Now router 4 has 3 serial port SC010, SC011 and the SC020. So router 4. Zero slash 1/0 IP address .0.0.14 mask 255.255.255.252. Now shut down. TSE 0//1/1. Then dot 0.0.17 255.255.255.252. Now shut down. /2/0 plus .0.0.21. Then marks 255.255.255.252. Now shut down. So R4 is finished. Next is R5 and R6. Enable config D interface gig port address 2.168.2.1 255.255.255.192 and now shut down. Get SE 0/1/0 address 10.0.0.18 now 255.255.255.252. The now shut down. Here also I will going to enable DHCP protocol. Okay, DHCP pull says site number 3. Work 192.168.2.0 marks 255.255.255.192 default router gateway 192.168.2.1 exit. And for the R6 also, let's do router number 6. Press gig port IP address 192.168.2.65 255.255.255.192. Now shut down. The address then .0.0.22 then marks 255.255.255.252. Now shut down. Here also DHCP will going to be enabled. So site 4. Site 4 network 192.168.2.64 subnet mask 255.255.255.192 and default router gateway 192.168.2.65. So all the router interfaces IP has been assigned, and the DHCP are also enabled on the routers where PCs are going to be connected. So let's go to first PC0. So let's check whether IP is coming or not. So DHCP selected, successfully assigned. So similarly for this PC number 1, so DHCP 1.56. Next is PC2 desktop IP. Then PC3 desktop DHCP. So all IPs are assigned. So now let's first configure OSPF routing protocol in the router 0. But before that, let's try to ping. What does it looks like? So let's ping from PC0 to this PC1 first, then alternately to PC just first test from PC0 to PC1 locally. 6. It says destination host unreachable. So let's first configure the OSPF routing protocol. For which we have to go to router 0. Router 0. So router OSPF process ID 1 network. We have to advertise our network. So first network is 10.0.0.0 and the subnet mask is 255.255.252, but we have to enter the wildcard mask, so it should be 0.0.0.3, the area 0. Next network 192.168.1.0 and the wildcard mask should be 0.0.0.63, area 0. Exit. So we have configured the OSPF in this router 0. Let's do for router number 1. Config D router OSPF process ID 1 network 10.0.0.4 wildcard mask 0.0.0.3, area 0. Network 192.168.1.64 0.0.0.63, area 0. Exit. So router 0 finish, router 1 finish. For router 2, router 2 config D router OSPF process ID 1 and the network 10.0.0.0 wildcard 0.0.0.3, area 0. Next network is .4 Since we have configured OSPF in all the three routers, so let's try to ping again from PC0 to PC1. So go to PC0 and let's see how our ping response looks like now. So now it's pinging. Uh, so similarly, we have to do the same thing for this router number 5, 6 and 4, 5, 6, which belong to OSPF2 domain. So let's go to router number 5 first. T router OSPF process ID to network 10.0.0.16 wildcard 0.0.0.3 area 0. The next network is 192.168.2.0 wildcard 0.0.0.63 area 0. So here router 5 finished, routers time for router 6. SPA process ID. Wait. Process ID to network 10.0.0.20 wildcard marks 0.0.0.3 area 0. Next network 192.168.2.64 wildcard marks 0.0.0.03 area 0. So router 5 finished 6. So now for router 4, enable. Before I configure the router 4, let's see one thing. Let's try to ping the ping result from first. Try to see how the ping response looks when pinging from PC number 2 to PC number 3. So let's ping from PC number 2 to PC number 3. So ping 192.168.2.66. Destination host unreachable. Okay. So now again let's go to router number 4. So config t router OSPF process ID 2 network 10.0.0.16 wildcard 0.0.0.3 area 0. Next network 10.0.0.20 wildcard marks 0.0.0.30. Jet. So let's now see again the ping result from PC number 2 to PC number 3. Now it's working for OSPF 2 domain also. Within its domain, by the use of OSPF routing protocol, uh, this packet is successfully delivered. Now let's try to check pinging from OSPF 1 domain to OSPF 2 domain. So ping from PC0 to PC2 and PC3. So go to PC0 first. So ping 192.168.2.2. Destination host unreachable. Similarly, 6. It's saying destination host unreachable. For this, let's assign BGP protocol to router number 3 first. So router number 3. port 50, router BGP, ESN number is 100, its neighbor. Here in BGP we have to define define our neighbor. So in this case, let's go again to the main screen. So as I'm going to open the BGP protocol, routing protocol. So at this interface, its neighbor will be this one, 10.0.0.9. Similarly, at this interface, its neighbor will be this one, 10.0.0.14. So get router 3. Number 3. So neighbor 10.0.0.9, and it's belong to which remote ASN number 30. This OSPF one domain belongs to ASN number 30. So this, and similarly 14. Next is table 14. ASN number belongs to OSPF2 domain, which is ASN number 50. Neighbor is 10.0.0.14. So now here I have this define the BGP routing protocol at the bodies, uh, defining both the neighbors. So at the edge router also we have to define the BGP routing protocol. So first do R2, then R4. So router BGP number is 30, and its neighbor ten dot zero dot zero dot 10. Remote ASN is 100. Then wait, exit. So R2 is done. So time for R4. Router BGP OSPF domain is ASN number 50, and its neighbor for router number 4. uh, its neighbor will be 013. Then dot 13 report ASN number 100. Now see, here I have this to find the BGP routing protocol with creating it network discoveries. Also they have discovered their corresponding neighbor also, but till now as this BGP has no idea how to get up to this address 192.168 series 1.0 and 1.0.0 BGP has no idea how to get, but this knowledge is with the OSPF routing protocol. OSPF routing protocol knows because OSPF has already advertised this network. So what can we do? We can transport the OSPF routing database into the this BGP. So let's go to this to the S router R2. So here what we need to do, router BGP, then ASN number is 30. Here we have to redistribute the database of OSPF 1. Okay. uh, okay, and also this the router OSPF 1, we also let the OSPF knows the this routing database of the BGP. So we have to again redistribute this the BGP database, routing database or routing table into the OSPF. So BGP ASN number is 30 and we have to put subnets, because if we don't put subnet then it will directly this classful address, it will be routed, but we have already this divided classful into this subnetwork, so subnet has to be put. Okay. So similarly we have to do for the S router R4. So router number 4, uh, so here also router BGP session number is 50. We distribute OSPF to into the BGP, then exit again router OSPF to, we have to again redistribute the BGP database routing table into the OSPF. This BGP is number 50 nets. Now since this we have enable both BGP and this OSPF and the edge router. Now let's try to ping from PC0 to PC2 and PC3. So PC0, so those 2.2. Now it's pinging. Before it was destination host unreachable. Now let's try to again ping 2.26, 2.6. Now it's pinging. So here by the use of BGP routing protocol, we can communicate this to OSPF domain. So in my next video, instead of this OSPF, I will do two EIGRP domain and and uh, and let BGP interconnect both the domain, and after that I will try to make a hybrid. One like one domain will be OSPF and another domain is EIGRP, and both of them will be communicating by BGP. So this is for today's video, which is OSPF to BGP to OSPF. So thank you friends.